Okay, let us continue working on the terminal. So C Matrix started printing new escape codes again, as it does every time I run it. I don't know how it or why that happens, but um, in any case, it's printing something now that can cause us to crash. So I'll have to look into that later. Besides maybe looking at what this capital T escape sequence is supposed to be for CSI. Um, let's just like scroll down. I don't know why it's thinking we're that kind of terminal, but uh, scroll down end line. So how did I? It's like insert blank lines. I guess does it. Yeah, it's just L again, basically. Who knows why that was even showing up? But anyways, we're not going to deal with that right now. So today, what I'd like to work on is um, escape sequences that are embedded inside of, or sorry, escape characters that are embedded inside of. Like it's not escape characters is the wrong term actually. It would be let me actually edit that. Control characters embedded in escape sequences. Um, so yeah, what can happen is basically if we just open up, I'm gonna add some stuff here. If we open this up, what we can just get is like escape um, number. Uh, let's say we're like starting a CSI color sequence. Oh, but then we want to move the cursor. Oh, then we print some like other number. Oh, actually, we want to like have a backspace to move the cursor again. Oh, maybe we want to have like a new line. I'm pretty sure new line's valid. Um, oh, let's put a tab here. Oh yeah, we were working on like an escape sequence. Let's just finish that escape sequence. So this is perfectly valid CSI set color sequence as far as I'm aware. Um, and so we should do our best to handle that. Um, now, it's being weird. Anyways, this might be like a problem with the way we're parsing our input into lines, but it also might not be a problem. So I think like right now, if we go to, actually just delete this. Let's go take a look at our split raw input into lines function. So this calls if we just have like something that's either an escape like 0x1b like a start escape or a new line. Um, we go and do some work here. And we just all we're checking right now is like if the cursor moved or if we need more bytes or if the screen swapped. Now, we go to our check if escape moves cursor function. So what we do is we start this and we go check if CSI moves cursor. So like let's say we start a CSI. Now the problem is we just try to like parse the CSI directly. So that's one way of doing it. Now that would help us. If we have like needs more bytes, we wouldn't split the line. That would work well. Um, but we would also start from we'd continue from like the start. So that could be like a problem. So we don't really want this parse CSI to just do that. Um, Now, this is like a problem because, well, let's for now just assume that this line parsing is going to work. Um, it might not, it might cause issues. And we're just going to work on let's assume the line was just split somewhere reasonable. And we'll just parse that. So when we do like our push line, instead of doing all this, we're gonna modify some stuff here. Um, and in order to keep track of the state, we need to do some other work. So let us add a new. So basically, we're gonna when we see handle escape here. So when we just see this character or this character, instead of doing this like handle CSI nonsense, um, we're going to start a new sequence, like handle CSI, handle OSC. Um, we're just going to start some state that says, okay, record the next bytes until the end of the sequence into like a buffer. And then after you're done doing that, we'll go ahead and parse that buffer at the end of the thingy. So we're going to add some new modes here. So we have like our TM mode. TM, like alt screen this thing. Let's add a new little enum here called the enum escape mode. And in escape mode, we're gonna have a few things. We're gonna have like a CSI sequence. We're gonna have a stir sequence, and we're gonna have well, I don't know about like stir. So stir would be like the OSC, but it could also be there's like a different one that also gives you like a stir. Maybe that's fine. Let's start with that. We're gonna do like the same flag thingy here, though it might be unnecessary, but we will see. And then in the terminal here, we're gonna have this. We're also gonna have this little enum escape mode. Escape. Okay. Now we go into this function here. We've just got this. Yeah, so this I think is gonna need to change. So well, let me think. So really, we don't really want to change this because we don't want to like have to necessarily make like a copy of this of the data. So like right now we don't actually make a copy of the data. We just store a pointer and advance the number of characters that we've seen until we find the end of the sequence. So probably what we want to do is continue doing that, but we're going to need like some way of clearing the sequence or restarting or like saving the state of the sequence, which seems like it could be a problem. So like ideally, when we start like a new line, we're not going to be in the middle of like a escape sequence, because if that's the case, we need to have like some way of saving a snapshot of where the where we were just in where we were in the middle of parsing some nonsense. So that is going to be a problem. Um, I don't necessarily want to just assert that right now, but it might be it might be important. So assert that T2 mode, T2 escape equals 0. So we're not in the middle of an escape sequence. We'll try that. Now, we'd like to do something here instead. We'd like to modify a few things here. So in handle escape, what we want to do is, instead of this handle CSI, really what we want is to do, we want to like set the escape mode. And as usual, I think in this case, having ST open to check what's going on there is a good idea. So I think it's called like escape CSI. So they actually have like a lot of different things here. We might need to handle some of this junk. So this is escape. This is the start of escape. This is like a control code function. Here they would clear this and they'd enter this escape start. Now in our case, I don't know about that. We might want to do this like resetting and clearing, but we probably, I don't even know how this is used. So this escape start is like weird. Right. So they just use that as like a flag to indicate that there's any escape going on. Interesting, interesting. So I don't necessarily want to do it like this. However, probably we still want to have like a reset CSI call, and then we want to set that flag, and then we want to break instead of the handle CSI here. Now this is going to be a problem. I might need to edit this in the other terminal because this is going to like break a bunch of stuff unless I can just write it all correctly the first time, which seems highly unlikely. Let's just punt on implementing the reset CSI here. And what we're going to do is we're going to say, in our push line, we're going to actually modify this loop a little bit. And what we want to do is, so we get a code point here. And instead of checking this switch statement, we want to do, before that, we just want to do well, there shouldn't really be an error case. I don't know if we're getting that anymore, but we're going to do something here. We're going to do T to escape. We're going to have to move these control characters into somewhere else as well. So what we want to do is so this part is just checking that it's like if it's a alphanumeric character, it will end the CSI. That part's good. This part will just increase the buffer thing, but if it's like a control character, I guess if it's a control, no, so if it's a control character, we actually have to move the cursor. So that's like the first thing that just gets tested here, is if it's a control character, then we do something else first. So probably we need that actually exactly the same way as it is in ST here. So now control is just set up here as is control. Probably we can add a similar macro. Is print is space. We'll have is control. And oops, did not mean to do that. Is control, I believe, is just like is between some numbers, right? So it's between that's right. So we can try this. We can do uh 0 and 0x1f, or so that's like totally fine. And really, this is C1, is C. We do kind of want to know about this, even though we're like assuming we're in UTF-8 mode all the time. Let's leave this for now. We're going to punt on this. But I'm going to call it the same thing just in case I decide to add it later. So right now, like our terminal only supports UTF-8 mode. We ignore the other mode that's not UTF-8. That's just like, yeah, anyways, ancient mode that I don't really care about. But so for now, we will do this in case we decide to add control C1 at some point, but I probably won't do it. So problem is we actually have to check if we're like starting an escape first. Where is it here? So like here, we do like all this nonsense. So some of this stuff is like really weird structure. We're not going to do it this way. Basically, this T put C is like this entire control statement. So really though, yeah, we're gonna have to handle that control character early. So maybe by the time we get down here, we're gonna just assume it gets copied into the buffer. Technically, that is correct. We'll ignore that for now. Though that might actually be related to the crashing. So like really like the stir sequences, which is like the OSC can just have any random character in it besides like Bell and some other characters that would end it. And this is some nonsense that we will not be participating in. So what we're gonna do is we are going to do if is control TP, and we're gonna do like a push control character, and it's gonna modify what we are doing down here. Oops. All these like push new line, push tab, all that stuff. It's all gonna fall under push control. It's the right place for this. Let me see here. Handle escape. So probably we're gonna have to put it below that function. Okay, so we're gonna do that. We actually do need to pass in the terminal. Then here we're going to we're gonna do like the same sort of switch code point. Push line. And we're gonna have to copy like basically all of this. Push control, I shouldn't have yeah, we're gonna do this. Unless we want to do it in that well no, we don't want to do it in there because I want to use this. I want to use this code, be able to reuse this function when I go to parse. No, actually we don't want to do that. We're only gonna handle it once. It's not gonna end up in the buffer. We're just gonna ignore it if it's in those CSI buffers, I think. Yeah, we're just gonna have to ignore it. That's the only thing I can think of. So uh this should all be fine. Until I go to modify this later, but we'll see. So here we're gonna have this. that's going to handle all of that case. Now, what we want to do is say, where we just called push control, we're going to change this. It's going to pass the terminal. It's going to pass, it has to pass a pointer to the line. That's a problem. Because, yeah, this line. That gets passed through as a line. We'll deal with that in a second. So if it's this, what we will do is I'm going to grab some of that code from handle CSI. Really, it's parse CSI. So this parse CSI function is going to need to get modified. Or what we could do is instead of doing what I just started doing with the state, is we could just say that this needs to like return. So this function here could just ignore control characters. It can't it can't ignore the control characters. It has to ignore them, and then we still have to handle them separately. So that's a problem. Yeah. Because when we go to parse, we still need to be able to get to the end of the buffer. That's a problem. The nice thing is, well, it's not really going to simplify anything here, though, because yeah, that's a tricky one. So push control. But for now, it's just going to do this check. We're going to do this is going to expand. We're going to have to like make it a global buffer though, that CSI buffer, or we're going to have to store it in the terminal. I think storing it in the terminal is not that bad. We do like t to CSI dot raw dot len plus plus. Let's go back up to where that was. So yeah, we're not going to do any of this stuff. We're not going to even, we're just going to fill in the buffer thing for now. So all we need to do is do this. Well, this is going to change some things though, but that's okay. I do like this just to still take this CSI pointer because, but how can we do this without messing with the line parsing? That's still a problem. Yeah. So some of this can get changed. Let's say this function does not clear the CSI anymore or set this raw. So let's have this sort of idea of a dummy value here, which can get filled in as we're parsing the raw. We're not going to set this anymore in this function. We are going to do these things. Okay, so this actually is starting to make sense to me. So this raw string, yeah, this is a tricksy one. Okay, let's I know what to do though. So this raw string can actually just be that CSI raw string that's in the CSI type def. This is gonna be like a bit cryptic, but maybe not that cryptic. So move this stuff out into the header so that we can shove it in the terminal. So in here, we're going to have a CSI. In here, we're going to have a, we're going to have some CSI here. Now it's just going to be the CSI. And what we're going to do is have this reset CSI. It's going to take the raw pointer and T to CSI. Really, it's going to take that and then raw. It's supposed to be a pointer. I guess it is supposed to be a pointer. Okay, so we're gonna do that. Then what we're gonna do is, oh yeah, sorry, my bad. This needs to be a pointer. I already changed that. Cool bug. I'll have to figure that out later. So now what we can do is we have this. So this is just gonna work fine. We need to have the reset CSI function programmed somewhere here. So we'll put that down here. We'll say static void reset CSI. And it's going to take an S8. It's going to take a CSI pointer CSI, and it's going to take a raw S8 pointer. Raw. Okay, and then what we're going to do is we're going to say that CSI to raw.data equals raw.data. CSI raw.len equals 0. Actually do this. gonna be kind of piggy about it. We're just gonna be a gigantic pig about it. That's all this has to do. Um, Honestly, that doesn't even matter. So no, we're not even leaving a to-do there for that. Okay, so we've got this. We got a raw going. Now if we go back to push line where we were working with this, so it's not a control character, but we're in a CSI, so we're gonna do t to CSI dot raw dot len plus plus. And we're gonna do this check. So if between space and tilde, probably. Oh, sorry, not space and tilde, between at and tilde. Those are valid for CSI characters. The rest of this is not. Or valid endings for CSI characters. If between code point at tilde is it just handle CSI? Would that just work now? We called handle CSI. So we don't have this anymore. We do have the raw. Now in the handle CSI case, this raw should really be right. In this case, this raw is gonna be it's gonna be T to CSI. We're not changing that interface. Sorry, my bad. So this raw is actually the T to now the only difference though is that if we go into here and we do this get ASCII, that's gonna like advance the start of the old raw pointer, which we don't want to do. Uh, how can we do this then? So really, what we kind of have to have this take like a copy of that raw string, and then somehow pass back how many bytes it just parsed, or -1 if it's invalid. Yeah, I think that's fine. Really, I think that would make sense. So this is going to take an S8R. We're still going to use this same sort of path here, but what we need to do is parsed characters plus plus. Let me think here. So we're gonna do that. Then we need to still do this like pointer advancing. Maybe we'll do this like manually. Or what we could do is let's do it a different way. Let's say start equals R. So we can still just use our get ASCII. Deleting the wrong thing. So we want that. Still gonna use our get ASCII function here. While r.len, this still just works. It's actually r.len in this case. That's fine. Here, though, we need to do something else. If, let's do it this way. Is control CP continue if it's between 0 and 9, do that. Then if we exit that, we can do the CSI. If it's neither of those, we do a CSI argc++. Then here we check the same exact thing we were checking before. And instead of returning 0, what we're going to return is start.len minus r.len. Which will give us the amount of things that we just parsed. And then if you get a -1, it's still an error. Then let's see who's actually grabbing this. So this ret doesn't actually matter. Now in the other place where we call it, I guess that's true. So does this need to actually pass this one in here? Or can it pass a null? I see. So, okay, probably we don't need the dummy one. Let's keep that. So if parsed equals -1, we do that. Oops, equals. Otherwise, we do consume. Does that function work? raw equals consume raw parsed. So that's going to be good for this case. And I think that is just about done for the handling the control codes in the CSI. Let's go over this quickly again. So let's go back to push line. So push line isn't, I didn't finish writing this. Actually just just delete that and delete that. Okay, so that looks good to me. So we can do that thing now. That's fine. Probably some of this stuff can now be joined then. Maybe not. It's like still really long. So here we're going to do some width finding. We're going to push a new line if we need to. Let's move this down here. So, okay, so now what we do is we come in here, we check, we get to see code point. We check if it's a control character. If it's a control character, we go to a separate function that handles that. If we're in escape CSI mode, and we're between this, we're actually gonna end, and we're gonna jump to handle CSI with T. What does this need? A raw value. Does handle CSI need that though now? So really it needs the terminal and the current CSI. And it doesn't really need this raw anymore, right? Like it doesn't use this. This is actually a problem, this one right here. Why? That makes this a little bit more complicated. Do they call it like CSI parse? That's for numbers. CSI handle maybe. Why it's a space? Wait, do they handle this one at all? Or is it like handled somewhere else? I don't think they handle that one. Then why was I handling that one? I typed the wrong thing. Thought that I had that set. I don't think they handle this one. I don't even know why I have this one. How did I get this one? I definitely think I saw it. Yeah, definitely some program sent that to us. That is garbage because exclamation point isn't even in here. Oh, I see. So it would be covered. Never mind. So this would still be covered because we had to have another character. Exclamation point wouldn't have ended this. We'd still just get that. It's not a control character. So yeah, we'd still just get that. And we could still just handle this. So that's fine. It's just dumb. It's like exceptionally dumb. We're gonna make this only take the terminal. Could also just take a terminal and a CSI potentially. Then we're gonna change that from get to peak. No, so like the problem is that this is gonna like not. Does this even? It does parse correctly. It parses correctly now, but it will have the extra p. The len is gonna be correct as well. Okay, this is weird. Yeah, this is weird. So okay, do I want to take do I want this to take the CSI? I kind of want this to take the CSI as a pointer. Even though we're storing it in the terminal. Okay, let's fix this. So we're gonna do CSI dot needs to become CSI arrow. Good old terrible thing that I hate doing all the time. And oh, this is I don't even remember how to escape this stupid character if it's in a X. I might just end up fixing this. I thought that would work, but maybe not. Okay, that one does. Okay. I need to fix this alignment. For many things, because it's all just off now. Okay, so what we're gonna do here instead is do peak CSI to raw. Oh, right. Oh, this is a funny, this is a quite the program here. Let's not have this return the number of the bytes that we have. We're gonna do this differently. We're gonna do SA raw is equal to CSI raw. We're gonna pass in a pointer to that. This is gonna take a pointer still. I think we determined we don't need the dummy. Don't need this, don't need this. It's gonna go back to returning 0. Forgot to fix that one earlier, that's okay. So here we can grab this raw, and then we can do peak or get ASCII or whatever. Okay, so I think this is getting somewhere usable now, possibly. Um, where did I forget to? This needs an arena. Um, see where I forgot to type something in a second here. Why was that? Oh, because my range was good. My range earlier when I did the thing was too much. I don't know why I'm passing a pointer to the code point. EM, CSI, right. Then 86. Forgot to finish typing what I was typing here. That doesn't surprise me. Okay. Let's run this. Oh, we forgot to clear it. So when we do handle CSI, why am I in this file? So either we clear it here, or we clear it in handle CSI. I'm gonna clear it here for now. Okay, so we're partially there. I don't know why this is like running if we are getting random garbage bytes everywhere. Also, this is gonna make it a little bit of a problem. I'll have to step through push line and see where the problem is. I'm actually surprised this is just working though. With such minimal, it was a pretty big change for it to actually just work, even though the characters are just obviously wrong. It's pretty good. So let's try. Uh, Doing it this way. Close this. We're going to go to terminal.c and we're going to go to push line because I want the first line to just help me with this. I really just want to break in here. So we are here. Didn't really need to do that. That's my bad. We're going to look at the line. Sure that's visible for people. Okay, so it's got our data in it as expected. So let us skip that. It's absorbed the thingy. That go into here. We've just got a thingy. So we're gonna go in here. We're gonna step into here. Go to raw. Didn't mean to do that. I need to fix that switch statement I see. I don't know if I did that. We're going to step into this. It's going to reset the terminal's CSI. Right now, it is garbage. Well, it's actually 0 because we haven't started anything yet, but we're going to reset it. We're going to set that to this first member of data, which is the 1, which is correct. Yeah, that would be correct. Right, and then we're gonna advance this, but we haven't actually. Yeah, if the code point is not the escape, we have to just yeah. So as long as it's not this case, we need to do this line. Why do I keep going into the wrong file? Push control. So clearly that was not the only problem. Is this... How have we, like, indented ourselves? Let's continue stepping this. So this would increase the... Where are we here? This is going to increase that length, but that's not quite right. Keep going. We already did that. We're going to skip over all of this. Oh, we need to put a continue here as well. That's another problem. Let's see where we're at. I think that was the only bug. Okay, cool. I'm actually surprised at how well that just went. I was not expecting it to go so smoothly because that is kind of a big change. So what we want to do is write a test that just does some of that stupidity and sees if it makes sure it works. Because, and especially the new line, that's the one I'm mostly worried about. The other characters I think are gonna work fine, but because that was quite the big change to go through and make. Wait a minute. I think it's actually a different bug. I noticed this earlier. I think there's like something weird going on in with like some duplicate lines sometimes in this mode. I'll have to look into it. Haven't been able to figure out why. Anyways. Oh, you know what? Actually, this one is covered by VT test, so I'll be able to find out based on what VT test just says. Why is that font not showing up? Interesting. Let me kill this for now. Move this to a different window. Close this, restart it. Okay, so let us write a test for testing this nonsense. We're gonna go into test.c. We're gonna do CSI embedded control. I think it's not spelled like that. So, like, just why this is even possible or allowed is kind of annoying, but CSI embedded control. And we're going to start by doing this. Probably most of this junk is going to stay, so we could actually honestly combine this with the I'm not going to combine it. You could probably combine it with this one though. Anyways. Of all of this. Okay, so this, right. So what I want to do, let me think. So also I'm gonna have to like manually type this now because I can't. Oh no, this will just wrap it. Never mind. Okay, so I think to start we're gonna do we're gonna start by just putting like an F at the start of the line. And then what we're gonna do is we're gonna start like this sequence. And we're just gonna put like a backspace here. And then we're going to finish the sequence. Let's do this in 2 steps. We're gonna have a new line 1 separately from pure cursor movement 1. Actually, no, I'm not. I changed my mind. What we're gonna do is we're gonna start the sequence. Then we're gonna do line 1. Let's call it line 0. We're gonna start the sequence. We're gonna do like a /r/n. Then we're going to so really what I want to do is actually manually mess with the cursor a little bit here. So we start on line 0. We're gonna do that. We're gonna print our line 0. Or print 0. Let's do this so we're not like embedding too much garbage. Then we're gonna go to /r/n and we're gonna print a 1. Then we're going to I don't want to like embed too many random things in here, but I kind of want to like move the cursor. Kind of want to move the cursor. So to do that, we kind of need to just move this around a little bit here. Yeah, we can do this. I'm just gonna manually move the cursor back. Feed a cursor. just do a cursor move to. Uh, 0, 0. We're just gonna move back to 0, 0. Then what we're gonna do is we're gonna start doing this. We're gonna start this escape sequence. We're gonna insert /r/n. Actually, no, we're not gonna insert /r/n. We're gonna insert /n. We're gonna leave this at the we're gonna leave this cursor at column position 1. We're gonna do /n, so it's just gonna go down. It's not gonna go to the start of the line. Then what we're gonna do is we're gonna do backspace in the middle of this. We're gonna finish our escape sequence. We're gonna print an R. We've replaced the character. We're gonna then assert that this cell is this. Yeah, this is ridiculous. This whole sequence is just complete nonsense. Well, that's how it goes. So I accidentally redefined this. So we're gonna fix that. And I'll leave some comments if this works, otherwise I'll fix it first. That's right, this is called the term. Okay, well, why is that? Let's figure that out first. Why are we scrolling up? Why is the cursor at the bottom of the window? What? If that's like the case, that's like some bug in our test. Row equals t to bottom. T to bottom just is 0. That would actually explain some of these bugs lately. I need to like set t to bottom somewhere. Where's term reset? Okay, so when is this being called? Because it needs to be called like somewhere at the start. First of all, this needs the this needs like the full terminal to be like allocated, so that's like a problem. Is this like getting set in main? No, but it should be. Gonna do that. Oh right, it's not called that anymore. Yeah, so we're gonna try that. Let's go in here and actually just run that. Here is where we're sig faulting. Go through the stack here quickly. So push new line, push control, push line. You got into here, we had like an L with a 1 and a length of 0. Blit lines, what was going on here in what's going on in the old blit lines here? So we had a terminal. Obviously GL is not initialized. That doesn't matter. Font thing doesn't matter. None of this should matter. I mean, this arena for frame probably is needed, but maybe not. Selection doesn't matter. Cursor does matter. These views need to all be allocated. This does have like just our data in the buffer. Looks like that one. Yeah, that one should be fine. So sorry, actually, yeah, this part of the stack makes sense. Where you have this line, it's got there's two lines because we filled one line in. And we just had like a 1. And then we're gonna, so then, this push control, push new line. So what is the terminal bottom and top? They should both be 0, right? Yeah. So they should be initialized. Are they, what's the problem here? Oh, we're not in the right, we need to go into here. Well, so these are all allocated. So I'm not sure, like, I just feel like, no, it's just, it's fine. It's really, it's just here we need to be calling term reset. We'll just term reset do. Let's just remind ourselves here. This will reset the cursors for us. So and it will move the cursors, I believe, as well. Yeah. So really, we just want to do term reset. Okay, so at least we can get to working stage now. So let's go up to that function and break in there and see what's going on. Here we go. We'll break here, we're gonna run. We don't have a T, we don't have this, any of this. The raw right now is that. Blit lines. Sorry. Let's do term. We have a terminal. Before we've just moved the cursor should be at 1, 1, which is wrong. Should be at 0, 0. Why is it at 1, 1? /R should move it to position 0. Okay, so before we've done anything, where is the cursor? The cursor is at 0, 0. Still at 0, 0. Go in here. Our line count is what? Why is this even set? Good question. Because T to GL is like not even a thing right now. Yeah, I'm not sure why that flag is set. Who sets that? How is that getting set? Probably I'm just forgetting how this function works. Or how this terminal thing is working right now. I wish the what's it called? The break on condition in GDB didn't suck so much. Because I'd like to see when that just gets set to not 0. We can try it, I guess, but I don't think it's gonna work. Especially because we're not gonna, and yeah, I can't track where the function. I'm gonna be able to figure out where we are, so that's not gonna work. Then in that case, let us just try. Let's just continue for now. I don't know why we have 23 lines. Hi, Anna James. How are you? What are we looking at here? So we want to look at the terminal cursor, probably. It's probably the only thing I care about right now. Zero, zero, line index 0. Step in here. So our line here is length 3, right? Because it's only going to be up to this new line. I'm doing well. So we added like a big feature, and we're just trying to write a test for it to make sure that I didn't do something wrong, which is always likely. So we're not in this. We're not going to do any of that. We're going to get 1. The cursor is still fine. We're going to fill in that 0. Going to step the column. We don't have a selection. In which language? C right now. Yeah, this whole terminal emulator is just written in C. Okay, so we still got some len. We're gonna get it. It's like /r. Step into here. I mean, that's just correct. It's not that. We're not gonna escape that. We're gonna continue. Yeah, that would be correct. Then we're gonna go in here. We're gonna get another /n. Step in here. We're gonna move to the next line. Step in here. Cursor position y is 0. Does not equal the bottom. We're gonna increase the row. And we're gonna move to. We're not gonna move to the first column. All of this is correct. This is still the same thing. We got the second line now. So that's correct. We're gonna go in. Oh, I think I'm just. Yeah, never mind. The line position was correct. It should have been in at 1-1. So let's go back to here. Let's continue. So yeah, that's right. I basically just stream for fun, I guess, at the moment. Just to show off some fun projects. So that's how the cursor is now. That makes sense. And we're gonna go over this. We're gonna move the cursor. Yeah, we just moved the cursor up 1 row, which is correct. We want to move it. Oh no, we want to move it to 0, 0 here, not 1, 0, 1. So we're gonna move it down and we're gonna replace the. Oh no, we do. We want to do this. Never mind. Sorry, my bad. What about making my stream look attractive? I'm not sure what you mean. I mean, definitely there's ways to like improve the stream, but it's not a high priority, I guess. Okay. So here we're gonna get this string. We're gonna shovel that stuff into the buffer. Shove an R at the end. Oh, we need to actually parse the lines and split them. That's what the problem is. If I actually knew how to write a test, then maybe the test would work. Adding designs like, yeah, the work you doing is something top notch, but presenting it with like adding logo, banner, stream, increase the number of audience. I mean, of course, but I should rebuild that before I retest it. Yeah, it's still failing. Let's see. Let's run. Do this, do this. Split that. We're gonna get 0. I guess that's fine, actually. We step in here. So we're gonna get a line index of 1. We're gonna go into here. No, I'm not interested, thank you. If I was gonna add a logo, I'd be the one to make it. Okay, so this line, let's take a look at this line. So this line has just got a 1 at the start of it, which isn't quite. No, actually, it is correct. What's the cursor though? x position 0, y position 1. That'll be correct. It's going to print this 1, then we're going to start the escape. We've moved the cursor ahead. Now we're going to start this escape. So step into here. We're going to get here. Let's step into this. So that's all good. It should be, yeah, 48 is where it would start. Then we're going to do this. It's going to not advance yet because we're not started. So, okay. So we're in this mode. We need to increase this raw length. So let's actually take a look at the term to CSI. Look at that one. Here's our raw. It's got a length of 0. It should continue all the way up until we get to this M. We're not between that. We're going to continue 2, 3. Which I'd skip over the... I definitely did skip over it. So the Y is now on 2. Right. So it's not actually a bug in the rest of our code. It might be. Well, it's actually not a bug though. It's how it is the expected behavior because of the way we're just processing these lines. Yeah. Okay. That's a thing, I guess. uh That's not a bug though. That's how it is. No, it is because well, no, it's not because we're not supposed to be able to move the cursor ahead in the middle of no time like that. So this is actually just a bug in the test. Um we can't just move the cursor randomly out of line like this. We have to do something else. How can I test this? This would just work fine in the normal case because the line wouldn't be finished. So if we want to just test this, what we should do is oops. Uh, how can I even test this? Because all the ones that just move the cursor are gonna split the line in the parser, which is like the correct expected behavior, but that just also means I can't actually test my stupid slash n in the middle of the... Okay, so that's correct. Oh, also we're not even checking the right row. It should have been rows 1, but really it should be row 2. Okay, what I'm gonna do is I'm going to see this one's gonna overwrite the anything I just shoved there. So really what I want to do is we're gonna still use this, but we're gonna put the backspace. Backspace won't clear the line. I'll be right back. Okay, I think I thought of the solution here. um so we can't just like the backspace. I don't know how to test the backspace. Besides, okay, what you could do. Okay, actually, I do know how to test the backspace. You basically write like one style to a cell, and then you backspace over it, and then you write the new style to the cell. That might have to be like two separate things here, though. So, so first of all, result.status is going to equal term the cursor dot position dot y should equal 2. It should be this, but what we want to do is so we're going to shove that there. Then we're going to do this. We're going to print the R. Then we're going to start a new escape sequence. Let's do it differently. Let's also put this in like a really ridiculous spot in between the characters like that. Okay, so that part is going to be fine. But what I want to do is so this cursor move is like completely useless. Let's go to that. So launder static string. What we want to do instead is we want to print something This is going to be line 2, I mean. That's going to be on line 2. We're going to print 2R. Why is that not focusing? I print 2L. Just randomly. Then we're going to... We basically want to assert two things here. So first of all, we want to check that the 2 has this style. Then we want to do another escape sequence with a backspace and an R and a default color, I guess. So, okay. Yeah, okay, let's do this. So first of all, first one should be 2. Then we're going to also grab another one of these, and we're gonna do... Where'd this 42 come from? Oh, sorry. Sorry, I'm misreading what I wrote here. We're gonna do this, and we're gonna do 48.2. This just sets the background. We could do 38.2, which would set the foreground. And then we're going to do a backspace in the middle of this. And we're gonna set the foreground to... let's actually just open the terminal thing. I want to see set colors. Let's do it this way. 0M. Then we'll do one slash BM. And then we'll have to do a different character, like R. Okay, this one should just work. So cursor reset, because I don't remember how this gets reset. Where did this like 3 come from? Oh, it's from this 33. Right. Yeah, that makes sense, but yeah, wait, I don't want to do that whole thing. We're gonna do this. Background should be the default background. Foreground should be the default foreground. And then 1 is adder bold. Of course, I did this wrong, and now I'm going to have to copy paste more stuff. cell 2, cell 2, it's not just y equals 2. Should be equal to 3 actually after we're done. And then, okay, so here, oops, oh, I just did. So here it's going to be 2. Actually, this is the same as this one down here. And the cell here is a 2. And the cell in this case is the, oops, should be 0 and 1, my bad. Okay. So, good. So, let us summarize what we just did today, and we're going to call it for there. So, CSI escape sequences and other escape sequences for that matter, which we can add later, are just allowed to have arbitrary escape code, like control characters, embedded inside of them. And so, what that means is that you need to be able, your terminal needs to be able to parse those without like just barfing and thinking that that the CSI ended early or something. Um, so in order to do that, we basically uh, added this terminal escape flags, which basically tell us if we're inside of a mode and we're parsing that mode. And if we're in that mode, we can do some like different actions. So if we're in escape mode, instead of like printing characters to the screen, we'll just increase like we're just gonna assume they belong to the CSI code, including escape codes. This is gonna cover escape codes as well. Um, like not this one, but inside push control, we're gonna cover the escape codes besides the starting one. And then when we go to parse it, we actually have to just ignore all of those control characters. Um, the raw buffer can still just have that stuff. So like we could actually dump the raw buffer as like an example, or dump the CSI escape, I guess, which I think still just works. Let's just quickly do that. We're not going to keep that in the test, but um, dump CSI just takes a CSI pointer. So if we go into our test here, I don't know what happened there. I'm gonna have to look into what just happened. That's okay. So if we go into our test, and what we'll do is after we're done with this one, we're just gonna do pound if one for now. That'll be if 0, dump CSI, and term to CSI. So here's our fun little escape sequence that just has 1 backspace M, and we parsed it appropriately to have a mode of M, what 1 argument, and the argument was just 1. So there you have it. Dump CSI. There you have it. We can handle random embedded escapes, including new line, in the side inside of our CSI. So that's a fantastic feature that terminals just have, kind of as a byproduct of them being giant state machines. So now we can just handle that. So cool. That is going to be all for me today. Thanks everyone who is here for watching, and I will hopefully see you all on the next one. Bye.